Okay, show the equation. Equation is given. Non-linear equation here, x ln x minus ln x minus 1 equals to 0 has at least one real root in the interval 2, 3. So we can use graphical method or we can use algebraic method. Algebraic method will be more easier because we hardly to draw the graph correctly, right? So we use algebraic method. What you need in Newton Raphson method is not equation only, we need function. So let the equation equals to 0. This one already given equation equals to 0. And we need to express it in function fx. Dah sama dengan kosong, kita kena samakan dengan fx. So your function will be x ln x minus ln x minus 1. So that in algebraic method, we substitute the first interval 2. Show your working. Then press calculator. And substitute value of 3. Show your working also. And then you press for the calculator for the value. When substitute 2 into the function, we're getting 0.307. This is negative. You have to put the symbol negative, which is less than 0. Is it? Then when you substitute 3, 1.197. Make sure your answer more than 3 significant. Like this one, F2 is 3 significant already. This one is 4 significant. You'll be alright. So this is positive. You make the symbol, D is bigger than 0. So come up with the conclusion. Since F2 and F3 have opposite sign, so follow through the sentence here. So your equation here has at least one real root in the interval 2, 3. Alright, so the first part of the question showing done. Hence, continue. Means continue from the function that we form here. Use Newton Raphson method. Show the iterative equation is this. So Newton Raphson method formula xn minus function over differential function. So what we need in differential function here, we need to differentiate this. Differentiate x with ln x, or x times with ln x. When we differentiate this, product rule. Product rule. So how to perform your product rule? U, V. Salin depan, differentiate belakang. Salin belakang, differentiate depan. Copy U, UV prime, then V, U prime. So differentiate ln 1 over x. Differentiate depan, x, we get 1. Then second term, differentiate ln x only. So it will be 1 over x. Differentiate constant for the third term, 0. Alright, so we simplify this. X times x can be cancelled. Remaining 1 plus ln x minus 1 over x. So we have to show the equation until this stage. Substitute your function. Close the door. And substitute the differential function. And then what can we see? We try to get same to the denominator until we can get this term. Alright, get same to the denominator first. This one, we have fraction over fraction. Alright, so for this fraction over fraction, you want to avoid it, get sent to the denominator x. So for 1, we time with x. Then for the second term, we time with x plus 1. So fraction over fraction, what can we get? Sn will be freed up. Okay? Okay? A divided by a fraction. So you will time with the B and C, you will need to time, so C up here, B down. So therefore, your Sn will be moved up. Time with your Sn here will be x squared. Alright, so we need to get sent to the denominator again. You can notice that your denominator will get similar already. Sn plus s ln x minus 1. Minus 1 plus 1. Do I do plus 1 minus 1? This one is minus. This one is minus. Okay. So x will be times the whole denominator here. So x times the denominator, there will be Sn squared minus plus Sn squared ln x, and x times negative 1. And then this minus is for the whole fraction here. Ln x, negative, negative, positive, x ln x, then negative, negative, positive, x ln x, positive x. Alright, so you remember to expand this negative inside. So what can we observe here? X squared ln x squared ln x, plus minus simplify. Right? Then minus x plus x, simplify. Right? Then what can we see here? We have an x here and we have an x squared here. In your final answer, you can see the x's have been factorized out. So therefore, we factorize the x, remaining 1x here, and then at the next term, remaining is ln x. So finally, you get to show this expression. X ln x minus 1, x ln x minus 1. Okay.